let's take a little example of reading from a file. We can define, let me call this example one, to a file object, open the file, my file one.txt. This opens a file for read. This is the same thing as adding the access mode of read or RT. This works the same way, and with T it works the same way, or because this is the default, it works the same way. So I'm just gonna do read mode, so you see the mode we're working with. This file actually exists in the same folder I am writing this code in. You can see there's a file called my file one here. It has some text in it, so I'm reading the file. After doing the read, I can now print out what I just read. File object, that's the object, and then I'll do read on it. That is, read out what you just opened. You can see here it reads out the output of that file. Let me do a print. So you see output of file one, then it reads out this output for me. You must remember to close your file. You reference the file object again, and then you put close. So this closes the file. It takes the file from the memory. Now, why do we need to close a file? If you don't close a file, it slows down your computer. Just imagine opening several browsers or opening several Microsoft Word on your computer. It occupies memory and then it slows down your computer. Write file may not write to disk until it is closed. If you write into a file, it's not all the time that it writes all the content into the disk. It actually writes it into the memory. Many times it waits for you to close the file before it actually writes all the file to the disk. So you need to use the close command on your file object to be able to have a full written file using the write mode. It's a good programming practice. You should do that as a good programmer. Your computer has a limit. The OS, depending on the OS you're using, it has a limit on the number of files that can be opened. So imagine you opening several files and not closing them. This becomes a problem. Open file in Windows are locked and private. So while file is open, you cannot read and write to it. So if you leave a file open, you can read onto it, you can write onto it. If it is open, for instance, a file that you need to be, doing some backup at the background, you can do that because it's locked. It's locked and it's made private. All the files, some programs will not be able to access it or work with it. File is usually managed by the Python garbage collector. If you don't close your file, the Python garbage collector will try to close it for you. It does it randomly, sometimes quickly, sometimes it takes a long time before the file closed, and sometimes those files are never closed. You don't want to leave that to chance. So having said that, the truth is many programmers will forget to close their file. That's why Python gives a garbage collector to help to do that. But Python provides an easier way to open a file and work with the file and not bother about closing it. Let's do another example. What Python do is it uses the with keyword to open the file. So you say with. I'm going to do the same thing I did right now. I'm going to open my file one again, my file one.txt. I'm going to open it for read as, file objects. Just the same way we do here, the name of the file. This is going to open it into here. Let me just use the word file. I prefer the word file. Then put a column, and then the file is opened. Of course, you can print out file.read. It's going to do the same thing. Okay, let me just pick this and bring it down here so we can have exactly the same code. So this is exactly the same code like we did here. But right here, I'm not using a close method. The close method is not used because I use the with method. When you're using the with method, the file object remains open. This file object will remain open for all the codes that are underneath the with block. The moment you exit the with, say you print right from here, the file object is closed. The moment I get out of the with block, the file becomes closed. Now let's use a variable that can help you to check that. That will be file closed. This returns a boolean saying if the file is closed or not. So is file closed? Let me just write here, is file closed. So I do is file closed. Let me remove this one. So is outputting these, is printing if the file is closed. Okay, let me print out the output. Print file.read. This first line prints out output of file 1. This second line prints out all this. Then this third line print is file closed, and then it returns false. So whatever we do in this block, the file will be open. Now, if I do this right now out of the block, can you see it's file closed? True. So while you are in the block, the file will be opened until you are out of the block. So Python will close the file for you when you get out of the block. Let's take another example where we open file 1 again as file. That's the file object. And like we showed you, you can just print the file and read out the content of the file. The open is like opening a Word document, and then the read is like reading a particular file on the Word document. This read reads all the file in one go, but you can decide to read it one at a time. Let me comment this out, and we can do for line in file, that is read each line of the file, and then I can print out each content in the line. So it reads every line in the file. It reads this first line, then it goes again and read the second line until it reads to the last line. And one thing you notice here is that it's not printing the way it was printing before. Now it's putting an extra line in between the lines. Let me comment this out and show you how it works before. This is how it was printing out. I mean, this is the representation of what we have here. But right now, when you print each line, it's print out leaving gaps. This is because each line has a carriage return. Though you're not seeing it here, but it actually has a carriage return, a \n at the back of each line. The \n is as if you pressed an enter, and that is why when it prints here, it prints a line, it adds the carriage return. So it's like you type this out, you press enter, you type this out, and then you press another enter, and then you type this out, you press another return key. So that is why it's printing out this way. Well, if you want to take out all that, you then have to use the string strip method, and you say strip out the \n, and you'll see right here it's printing out the way it's supposed to print it out, because I'm stripping out the last \n that is automatically attached to it. So if I can print out each line, then I can actually manipulate the content of each of the line. So let's add a line number to it. So I'm going to initialize a line number. And right here, I'll say line number plus equals 1. So I'm increasing the line number as I loop through, and in here I'm just going to add the line num. So right now you see it's having line number before all the contents, and this is exactly how it is displayed in the editor file itself. You can see it has line numbers all by the side, and in our code here we also did the same thing. We added line number to the content that is displayed. File read will read out all the lines, but I can actually read out just some characters in the line. So in this place I can just read out 50 characters. So it's going to read out only 50 characters, 10 characters. It's going to read out only 10 characters from that. Another read that we can use is the readline command. Readline command doesn't take in a parameter, but it reads just the line. Readline. So it's more like, using the for statement to loop through the line. We also have the readlines. What readlines does, it reads all the file and store the result of the file you read into a list. This you should do when the file is small, because it actually reads everything into your memory. So if you have a very big file, that will give you a lot of memory issues. So if I say readlines my list, so it stores each item in a list. Print my list. So you see, it is a list. Here you can actually see how each line is done. You can see that there is a \n at the back of each line. All right, so let's look at some important method that file provides. On opening a file, a pointer is created. We talked about pointer when we were defining all the access mode. On opening a file, a pointer is created which reads the file starting from the beginning or at the end, depending on where you want. But like I said, the pointer is like the cursor. Where the cursor is, where you start reading. The pointer, when you read, starts from here. When you write, starts from the beginning. When you're appending, the pointer is at the end. Of course, if you want to append the document, you're going to be appending the document at the end of the file. So the pointer starts at index 0. Index 0. So if you want to see your pointer, let me open up a file and print out a pointer. You use the method called tell. Let's do an example. Tell will tell you exactly where the pointer is. So I'm going to print out pointer at, so we'll say file, that's the file object, dot tell. So it tells me that it is at index 0. Pointer at index 0. Now, if you want to move your pointer to a particular position in your document, you use the seek method. Now, what seek does is it moves. It's like taking your cursor and placing it here. You just did a seek. So you seek to a particular position in your file. I'm going to do file seek 50. Now seek 50 means move to line 50. Now if I check my pointer now, if I print out my pointer, you see it said my pointer right now is at 50. Initially it was at 0. That starts at the beginning of the document, but now it's somewhere in the document, is on line 50. If you read, it drops the file pointer at the position where you read to. So let's say I read 50 characters. So it's going to read all these out. It actually does this. It reads and stops here. Now the pointer is here. You see, the cursor actually is the pointer. So if I say, now tell me where the pointer is, I'm going to double click, do this right now. I said, tell me where the pointer is actually showing me that the pointer is at 52. Now, why did he add the 2 up there? Because it also reads the 2 characters and the carriage returns. That's why you have 52 there. So I did read this, and if I read these again, you see, it's not going to start at the beginning. This is the same code. Okay, let me remove this. When I read this, this is what came out. You see that? But when I did the same code, this is what came out. So majorly, what this means is that when you're reading a file, the pointer is at this point. You read through the first 50. The pointer is at this point. When you say read again, it's going to start reading from E. That's what you saw here. Because this is where the pointer is. This is where it's going to start reading from. It read to this point, to the space here. When we said 50 again, it started reading from here, and let it S, and then it stopped at this place. So you see, you need to put this in mind. When it reads down. If you want to see where the pointer is, when I read the first one, the pointer is at 52. When I read the second one, the pointer is at 104. So it's actually increasing the pointer. So if I do another read here, let me put the pointer again. If I do another read, this read from point of 156, we'll read this out. Now, if I try to read again, you see, we stopped at let it shine. If I try to read again, it's not going to give me any other results, because actually the pointer is at this point. And so you're just trying to read the blanks. There is nothing there. It's not going to give me any other result because I have gotten to the end of the file. It has read to the end of the file is 156. If you want to tell where you are, like I said, you use the tell command. I can pick this now and put it in between. It's going to tell me, okay, the last pointer is at 188. If I put this here, it's still saying it's at 188 because that's the end of the document. At the end of the document, you are unable to read any other file because there is no other thing to read.